Hello everybody, Zero Fossil Fuel. Today is Sunday, February 5th, 2012, and this is your first Zero News update of the year. So, Happy New Year everyone. Want to bring you up to date on some of the projects that I've been working on. I know a lot of you have been wondering why I haven't posted recently. Got a lot of things going on, and it's pretty cold out. But first of all, I want to say that during this election cycle, one of the burning questions that seems to come up an awful lot is whether or not Ron Paul can beat Barack Obama in a general election. So I just wanted to test those waters and I put up a quick poll at altenergy.org. I'll post a link to it. It's right on the front page, alt-nrg.org. And just the preliminary results with the few votes that I've gotten already, I think are a pretty clear indicator that if Ron Paul were to win the Republican nomination, that he would handily defeat Barack Obama in a general election. There's no doubt about that in my mind. This is the first time I've really been as involved in the political process during any election in my 30-plus years of marriage, as pointed out to be by Mrs. Z. And she blames Scarecrow. And Scarecrow says, well, may as well blame me because my wife blames me for everything too. So, Scarecrow, thanks. Mrs. Z, thanks you also. Today I was supposed to interview Hillbilly, who happens to be on assignment and staying in a hotel not too far from where I live. Unfortunately, he was recalled back to his home state, and he will be back out next week. But I did want to interview him and talk more about the M1 SGU from Vulcan Gasifier, which is his company. A lot of people have been interested in the gasifier that he has designed. It's a very compact unit, very clean running unit, and very easy to maintain. He is also working on a prototype now for the E1 SGU, which is the big brother of the M1, and should be able to be large. It should be large enough to operate up to a 50 horsepower internal combustion engine. So pretty excited about that. I have his permission to use these images, and I can't wait to actually do the interview and discuss in detail the products that he has been working on. You know, a lot of us neglect alternative energies that have already been proven and tested. So this is not exactly in keeping with the fringe science experimenting that some of us are doing, but this is a definite excellent stopgap in between. I mean, think about it. What would you do if the pumps stopped running tomorrow? And a gasifier is definitely an alternate means for powering internal combustion engines that you absolutely have to have in order to exist in a modern society. And this is a really excellent product. So on to what I've been working on now. Scarecrow some time ago interviewed Wesley, who was working with a couple of people in Lithuania and England, and they were replicating the Kapanadze device, and I thought it was very interesting and definitely up my alley with the RF engineering background that I have. So I decided to undertake this project and put the Muller motor project aside for now until I can test the practicality of replicating this device that Wesley had shown. So the first prototype that I put together was with a standard toroid transformer core that was sent to me by Keith Turtle. And this is a fairly large toroid ferrite core. It's about 4 inches outside diameter, and in this photo you see that I have layered a couple of strips of copper along the inside and outside diameters with a bridge across the top on one end, forming sort of a half loop primary that is transverse to the core itself. In this photo here you see the terminals that I've added and soldered that allow me to attach the 2 wires to the other end of the coil. Here you see the coil being wrapped with electrical tape for the first winding that goes on top of that, a standard winding, which was the 50 turn coil that goes on top of the 1/2 turn copper strap. In this photo you can see where I have finished the first 50 turn coil and begun wrapping it with electrical tape to receive the 15 turn primary that goes on top of this. Now you can also see in this photo where I have taken the ferrite core now and scored it with my diamond blade for the Dremel tool, and then snapped the core in half so that I can create an air gap on the ferrite core as required to keep the core from saturating under normal operation. If you look in the top right hand corner, however, notice how close the copper strap is to the edge of the ferrite. I ended up having to abandon this particular model simply because I forgot to put an insulating layer underneath the copper strap to insulate it from the ferrite core, and when I energized it with high voltage I ended up getting arcing from the copper strap to the ferrite core, which quenched the signal that I was trying to send into the core. That was kind of unfortunate, and I probably will rebuild this core at some point. Here's a close-up view of the 15 turn coil wound on top of the 50 turn coil. And here is the other half of the ferrite core with the 22 turn bifiller wound coil. You'll notice how the pairs of wires are kept parallel all the way around the core. It's very important when you're winding a bifiller coil that the two wires that you're winding be maintained parallel, side by side, all the way around the core. Here are the two halves of the cores fully wrapped with electrical tape and shown assembled together to give you an idea of what the whole assembly looks like. And here it is on top of the first prototype of the high voltage circuit that I attached to it. I just strapped it to the plywood, and in the top right hand corner you'll see where I have a small printed circuit board. This is the driver circuit for the flyback transformer that's just below it. That flyback transformer was salvaged from a Dell computer monitor. Couple of spark plugs, and they are simply held onto the board by a standard glass fuse holder that was snapped in half. It was just the right size to receive the end caps of the spark plugs, and the two electrodes are simply spaced together by a piece of PVC clear pipe. Also in the photo you see a air variable capacitor. However, this air variable capacitor did not have enough range to adjust the resonance of this particular core. Here's a close-up of the high voltage arc between the two electrodes of the spark plugs. Now I ended up having to abandon the plywood as a base because I ended up finding out that the plywood itself retains enough moisture to bleed much of the high voltage electronic energy that I was trying to send to the coil away from it. And you could, when I turned out the lights, I could actually see a coronal buildup between the spark plug and the plywood below. So ultimately I ended up having to build the circuit on a plate of glass. After I decided to abandon the standard ferrite core, I chose a ferrite core that was dimensionally much closer to what Arunus from England was experimenting with. So in this photo you see the 1/2 shell with the copper braid strap. You'll notice I have insulated the ferrite core now in advance of putting the braid on it. The braid simply layered underneath this 50 turn coil in the center, goes up over the top on the left and then back around the right hand side so that I can attach my two wires to it. Here's a look at the back side of the 50 turn coil, and here is the 15 turn coil, again layered on top. This is the same design as the toroid ferrite, however this one is wound on the bell-shaped ferrite core. Here's a look at the 15 turn coil from the inside of the bell-shaped ferrite core. And here is the bifiller wound secondary half of the bell-shaped ferrite core. Again, notice that the wires are kept side by side in the bifiller wind so that the coils will retain as much energy, which is the benefit of having the bifiller windings. Again, a look at the inside of the bell-shaped ferrite. This is the bifiller 22-turn secondary. And here is the assembly now put together on the plate glass with rubber feet. The glass acts as a much better insulator than the moisture-laden plywood that I had originally built the project on. You'll notice in the lower half of that plate glass there's also a toroid core. This is actually a toroid core that I wound as a Rodin coil, so I'll be experimenting with that as well. Off to the right you see a couple of additional ferrites that Wes 351 sent me. Here's a close-up of the electronic circuit board and the flyback transformer again. The blue heatsink is attached to the transistor that is part of the driver for the flyback transformer, and the silver heatsink is the 3-channel deflection plate amplifier salvaged from a television set. Now, in order to actually perform the measurements that I needed to perform to find the points of resonance, I needed to construct what's called a return loss bridge. And I'm pretty proud of this little gadget. If you notice, those are BNC connectors, so that'll give you an idea of the overall size. It's probably only about less than 2 inches long from left to right there. And it's a very compact little unit. Here's a look at the inside of the return loss bridge, and what this device is used for is to attach to a radio test equipment service monitor, such as the R2670 by Motorola, which I use on a daily basis during my regular work day. So I have access to this very sophisticated piece of test equipment, and with this return loss bridge I'm able to actually sweep wide ranges of frequencies and put a device under test and actually find what the resonance points are of a particular device under test. Alright, so what I'm doing right now is I'm just zeroing in on the lowest natural resonant frequency that I was able to obtain with the existing core assembly, which is right here, and this variable capacitor, along with my my capacitance decade, that is currently set to 0.0005 microfarads or 500 picofarads, along with whatever variable capacitance I have on this air variable capacitor with the smaller Dell monitor ferrite core. And the lowest natural resonant frequency that I've been able to record is 6.614 megahertz. To verify that, right now my range is at plus or minus 5 megahertz. I'm going to zero in to plus or minus 100 kilohertz, and we can more clearly see exactly where the resonance peak is. And I'm going to slowly increase my frequency. Right now I'm showing 6.614
630 megahertz as the lowest natural resonant frequency for this particular coil and capacitance network. So I do need to rewind this coil with the larger ferrite core assembly, and just to give you an idea how much larger, okay, here is the core assembly that I pulled from a Dell monitor. This is the core assembly that I pulled from actually that Wes 351 sent me, and the largest one that Wes 351 sent me, which is much closer, in fact almost identical to the core assembly that Arunas is using in England, who was collaborating with Wesley for his Kapanadze device. So I will have to rewind the coil assembly onto this core to get a lower natural resonant frequency than I am obtaining with this particular core right here, and I will reconduct the experiments so that I can get the frequencies down into the range where my signal generators, this one here is good for up to 1 megahertz, and this one is good for up to 100 kilohertz. The Heath kit. That one is a precision signal generator right down to 0 kilohertz. I mean, it's a good signal generator. It's an audio signal generator, and this one is an RF signal generator. So that's where we're at, and progress continues.
So that's it for now. I hope everyone is well. Hope the team you're rooting for wins today. And I'll catch you all later. As always, peace.